Hey everybody, this is Larry. This is day 8 of April. Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think. Today's, my glasses are back, and also that's the wrong week. So yeah, let me know what you think. And today's problem is letter combinations of a phone number. And I'm, solving these live, so it's a little slow, fast forward, 2x, whatever you need to do. Watch another video if you like, but okay, let's see. Given a string containing all the digits from 2 and 9, return all possible letters that can, okay. Return the ends in any order. I guess that doesn't matter. We'll put it probably in the right order. Okay. I would say for these problems where you have to return all possibilities, very often it's going to be exhaustive recursion or something like that. Reason being that, if you do things in a reasonable way, because you have to return all of them, and in this case, there's not even any filter or like, constraints or anything, that means that you can only do as quickly as there are a number of possible combinations. And in this case, it's going to be exponential because that's just how these things work. Not going to go over the exponential part too much because I think there's a lot of literature out there, and if you're not familiar with that, then you have to do some maths, but we'll do some preliminary things. Okay, and the key, one actually interesting thing to know is that the length of the digits is only 4. So that makes it even easier because, well, you only have 4 digits, and each digit can have up to 3 numbers, or 3 or 4, I guess 4 letters, but let's say 4 letters each. So that's going to be at most 4 to the 4, which is, what is that, 2 to the 8, which is like 64 or something like that, or 128, whoops. So that's like a very rough upper bound. So knowing that there are only 128 possible answers to return, we can probably even, do something crazier. But we're gonna write a more general answer and go that way. Yeah, okay. Note that what I'm gonna do is recursion, but there are a lot of ways to do it, and sometimes, especially in Python and maybe some other languages, it's very easy to hand wave the complexity, and also just get the complexity a little bit off with respect to the memory construction and usage. And memory, you might not get into memory limit error. You might still use so much memory just from needing to create memory usage on the stack that it might time out. In this case, I don't think it matters, like I said, because it's 4 to the 4, and that's not, some letters only have 3 digits, or the other way around, some digits only have 3 letters. But that said, if you are doing a big thing, we might have to be careful about how you implement it. And what do I mean by that, we'll go over in a second. So I'm going to do things in a little bit weird way for a result. Okay, so I'm going to do things how I would do it in a Pythonic way, and then we'll maybe tweak a little bit to go over what I mean. I think that'll be good. So yeah, we can do this with a recursive thing. So let's just say, how do I want to call it? Naming is hard, but let's just say generate. We have index, and I guess that's probably all I need because digits already contains the digits. But let's go back for a second. N is equal to length of digits. We also need this mapping, which is a little bit awkward. Usually they let you, maybe not usually, but I guess this is actually more like old school days. But but sometimes they have a thing that you can copy or paste a little bit better and then parse or something. So yeah, so let's do that. So let's just have an array of strings. So 0, 1. I wish this is like side by side so I can see them at the same time. And then 2 is A, B, C, D, E, F. I hope G, H, I, G, H, I. Is that right? Okay. J, K, L, J, K, M, N, O. Because I keep on looking up because I didn't know which one is the 4 P, Q, R, S. So it's that one, and then the last one, right? T, U, V. W, X, Y, Z. All right, so these are the mappings. Is this enough? No, this is not enough. But yeah, but let's just say current progress maybe. Yeah. So with our base cases, if index is equal to n, then let's pretend this is a string for a second. So yeah, so this is the current string. So then you can return, let's just have an answer. And you can also implement this another way. I'm going to abuse the it's not really global, but the functional scope for a little bit because it's a little bit easier to handle. But you can imagine that you can actually return an array here, an array containing one element, and then propagate that up. For certain problems, you actually have to do that because you're taking, depending on what the problem is and how you generate them. But for this one, this is okay because you can imagine that maybe there's a divide and conquer thing where like you have a left array and a right array, and then you have to merge them in some quadratic time thing. But yeah, okay. Let's see. So then now we just have to I was gonna say, okay. I was gonna say, do I have to check for 0 and 1 because they're not in there? So okay. So then now we get digits of digits of index, and then we look at the mappings of this. Of course, this is a string, so we have to convert this to an int. So I think this is okay. So then now we go for character in this. We generate index +1, current +c. And I think this is good enough, to be honest. We generate from the 0th index, and our current is an empty string, and then we just return answer. I think this is going to be good enough unless I miss something really silly, which is, which has been possible. So yeah. Okay, let's get some more to, I don't know, 299, 9, something like that, right? Oh. Okay, so we did have a wrong there for the base case, but how do I want to handle that? That's a little bit awkward, actually. I mean, I think their answer is more correct, but I guess that makes our base case a little bit weird. We could do this, I suppose. But this is a little bit expensive, but we can do it another way as well. But for now, it's just trying to get it correct, and then we can make optimizations afterwards. So yeah, so this is going to be looking good, I think. Yeah. So the thing that I was talking about is that because here it's very easy for memory and stuff to creep, because we create a new string every time on every recursion. So there are other ways around it, and I implore you to kind of explore some of them. Some of them include, using an array in which you push and pop at the same all the time, and you only construct the string at the very end, for example, because here you have a lot of dangling strings at some point, and maybe gets garbage collected, and I don't know, it depends on how things get long and stuff like that. But yeah, and there are ways to do it, but I'll leave it up to you to figure out. So what is the complexity of this, right? This one is a little bit easier. I don't with constraints and stuff like that, it's sometimes a little bit trickier to kind of prove a tighter bound. I mean, you can prove an upper bound, but a tighter bound is hard, especially when that test the cases. Let me submit it first. Let's see, maybe I missed something silly. That'll be sad. Okay, cool, accepted. My confidence has been low lately, as you can tell, because I've been doing a lot of silly wrong answers recently. But yeah, so what is, so the index, this can have, index can go from 0 to n, that's obvious. And in each case, we branch out, let's say 4 times in the worst case, right? 4 times, oops, how did that happen? 4 times, I'm branching. So this is just going to be n to the 4th at most, or n to the, somewhere between O of n to the 3 and n to the 4th. So that's basically the idea. And this 4 kind of, if you really want to be technical about it, it grows relative to the size of the alphabet, roughly, if you want to, I don't know, depending on how you want to do it. But yeah, but that's going to be roughly the answer. Cool. And in terms of space, well, you really cannot do better than n to the 4th as well, because that's the number of things that you are going to be returning, right? That said, like I said, we do construct a lot of extra space in general, but that's going to be also to the order of n to the 4th. It's just that it's a little bit messy. Anyway, that's all I have for this problem. Let me know what you think. Hope you have a great rest of the week. It's Thursday already. I was gonna say it's Wednesday already. It's Thursday already. Hope y'all have a good weekend. See you tomorrow, and stay good, stay healthy, to good mental health, and I will see you tomorrow. Bye bye.